Hello everyone, it's Benny, and welcome to video 2. In this video, we're going to be creating a display, someplace we can draw in using OpenGL, and that's what we're going to do in this video. So first off, I'm just going to get rid of our temporary include right here, make sure everything still builds and runs, nothing's broken. Alright, great. And now we're going to start. If you want, you can actually do this in the main method, but what I'm going to do is I'm going to do this in a new class. So I'm going to create a new class. I'm going to use CodeBlocks' class wizard. If you don't have this because you're not using CodeBlocks or whatnot, don't worry. You'll see how to do this in code in just a moment. So now for the class name, I want it to be display, and that's good. I want a copy constructor and an assignment operator because that's my convention. If you have a destructor, then it's virtual and it has copy constructor and assignment operator. I do want them to be lowercase just because that's also my convention. I like having header files and source files being lowercase. And other than that, I do want them in the same folder, nothing with that, and it should be the folder of the project, so nothing surprising there. Other than that, I think that's all I want. So I'm just going to go ahead and click create. And yes, I do want to add them to the project. And yes, I want to add them to both configurations. So there, now we've created a class. And now I just want to reorganize a couple things. First off, I don't want my copy constructor and my assignment operator implemented. And the reason for this is I haven't found I needed them, so what I'm going to do is I'm going to take them in my header. I'm going to move them to private. And I'm just going to put implement as just 2 braces with nothing. And I'm going to tab everything back 1 because, that's how I like formatting my code. Going to have my destructor like this, just because, again, that's like how I have things formatted. Other than that, yeah, we got our basic setup. And, okay. So now, in case you're wondering and you don't have it, this is what the code is going to look like. And this is what's going to look like for just about every new class I create, so that's what I'm going to be using the class wizard. So, there you go. Hopefully this won't be too hard to type out. I just don't want to spend video time typing this whole thing out, and yeah. So anyways, now for my display, I'm going to take in 3 parameters. A width, a height, and a const std string reference called the title. So a string for the title. And that means I'm going to need to include string for the string. And there. These are just the parameters I want to take in. I found that's what I like specifying, so most often that's why I'm putting it in the constructor. And there. So it's going to take it in my actual implementation. And really, all I'm going to do right here, for the time being, just going to include IOStream. I'm going to copy what I have in main, which is the hello world. Just going to print out, constructor, exclamation point, and in the destructor I'm going to print out destructor, just to make sure everything's working. So, going to include in main display.h, our new class. I'm going to get rid of hello world, and I'm just going to create a new display called display, taking in 800 by 600 and a title of hello world. Just to make sure everything's working. Gonna hit Control F9. No return function. That's okay with me. Well, okay. Yeah, fine. It doesn't matter. Let's run. And cool. Everything's being called. So there. That means at least our class setup's being done correctly. And at this point, we can, for one, get rid of our temporary code because everything's being called correctly. And we can actually implement it. Okay. Now that we got our framework set up, our goal, like I said at the beginning, is to create some area on the screen that we can draw in with OpenGL. And this is a little bit of a tricky process and varies a bit depending on what your operating system is. So I'm going to be using SDL2 for this, and I'm going to be using it to create a window and do all that stuff and setting up everything. So first off, I'm going to go to my display.h, and I'm going to include something else. SDL2/SDL.h. So now we have access to all the SDL functions in our display. And the reason I want to do it in a header is because I need a private variable here, SDL window, an SDL window. Now I don't want to actually store the entire window in my display. I'm just going to create a window pointer so I can refer to it, as a pointer, not as, oh, here's all the data stored in the display, none of that. And yeah, so I'm just going to call it m_window. So there, now we have a window that we can create with SDL. So this is where our constructor and destructor are going to come to place, because we're going to want to take our window and assign it something. But before I do that, I need to actually initialize SDL before I can use it. Now, here's the thing. If you're using SDL for more than just windowing, you might not want to do what I'm about to do within a display class. You might want to do it outside, maybe in your main method, maybe somewhere else. Because I'm only using SDL for windowing purposes, I know it's safe to do it here. You might want to do it differently. But I'm going to initialize and deinitialize SDL in my display because of exactly that. I'm using SDL just for windowing. And when I initialize it, it takes in a parameter of what exactly I want to initialize. I'm just going to pass in SDL_init everything because I don't want to bother with the whole, oh, we need these components but not these components. Just going to make it easy for you guys. Just going to make it, we initialize everything. And our destructor, again, very simple, SDL quit, which deinitializes everything. So cool, we've initialized everything, we've stopped initializing everything. What now? Well, now we create the window. So our m_window is going to be equal to SDL create window. And this takes in a few different parameters. First off, it takes in the title, but here's the thing. SDL is a C API and not a C++ API, so therefore it won't take in the C++ string. So I want title.c string for the C equivalent string. And now I can specify where I want the window to be created, like in my screen. I just want it to be in the center, so I'm just going to say SDL window pos centered for both of these. And that's convenient. It just automatically puts it in the center of your display, no matter how big it is. Width and height, of course, want width and height. And then flags. These are like special characteristics you can pass in, like how many buffers you want, if you want double buffer display or not, or if you want SDL. There are a whole bunch of different flags you can pass in for SDL to make it create the window in slightly different ways. That's what this is. And I only want one thing here. I want SDL window OpenGL. So SDL knows, hey, we're not going to be using SDL stuff to draw in this window. We're doing this stuff with OpenGL. Now, because we are using SDL window OpenGL, we actually can set a few additional parameters that aren't part of the create window method. How do we set them? Well, we set them with SDL_GL_set attribute. And that sets a few different attributes that will be set when we create a window with the window_OpenGL parameter. And there's a few of these I want to set. For instance, I want to set SDL_GL_red size. This is the number of bits that are used for, well, displaying red colors. You can think of it, it displays this many bits of shades of red. So, for example, if I set this to 8, it would create 2 to the 8th power, which is 256, different shades of red. And if you're not sure about these values, 8's generally, or for any color, 8's generally a good value to go by, because the human eye discerns about 256 different shades of one color. So yeah, 8's generally a good value to go here if you don't have, or to go by if you don't have anything else that you need to set it to for some reason. So, other than red, there's 2 more, green and blue. Also want those. So there, we have 8 bits for red colors, green colors, and blue colors, and 1 more for alpha, which is how transparent it can be. So yeah, we have 256 different shades of it. So yeah, in total we have 32 bits of color data. Another parameter we can set here, though, is the GL_buffer size. This is how much data in bits that SDL will allocate for a single pixel. Now we want all this data, the color data, for every pixel, so I'm going to set this to 32. Because, well, we have 32 total. And one thing to keep in mind with all these values, one of the things with SDL is it's not saying that it will give you 8 bits or it will give you 32 bits or whatever you set it to. It's saying it will give you at least that many bits. So be a little bit careful here. Just because you put in 8 doesn't mean you'll get exactly 8. And the final parameter we want to set is SDLGL asset attribute to SDLGL underscore double buffer. You set this to 1, and what SDL is going to do is it's actually going to allocate space for 2 windows. It's only going to create 1, but it's going to allocate space for like a second area you can draw in that won't be actually be displayed. And that might seem a little bit weird at first, but if you're not sure about double buffering already, I'll talk about that when we actually start using it. But we do need it for a moment, don't worry. I'll go over it when we actually use it. Now, it's at this point that things get a little bit tricky to visualize. So I'm going to do some basic illustration just so you have an idea of exactly what's going on here and, well, so that what we're about to do makes a little bit more sense. So let's start with what we have right now. Right now, we have SDL. And what we can do is we can talk to SDL, we can send in commands, we can say, hey SDL, create us a window, do some stuff for us, and SDL says, okay. It goes to the operating system, because it doesn't have control over the windowing system, the operating system does. And it goes all the way down to the operating system, sends it all the data we gave it, and the operating system does whatever its magic operating system crunching is, and feeds us back a window. Nice, managed, under complete control of the operating system. And then SDL gives us that window. So yeah, that's pretty much what's going on right now. And of course, this is going to cause a little bit of a problem, because if we want to do, say, drawing in that window, we're going to need to use OpenGL. Here's how OpenGL works. OpenGL takes your commands, and it sends them to the GPU. And that's very fast and efficient. And if you want to send the GPU into the window, well, that doesn't work. The GPU isn't what's sending data to the window. The operating system has total control over it, and it's not letting some arbitrary GPU command into it. So this is what the GL context is going to do. What this is going to do is it's going to take what we've done so far, and it's going to sever the... I shouldn't say sever, that's not entirely accurate, but it's going to greatly decrease the control that the operating system has over it. What it's going to do is it's going to say, okay, the operating system isn't what's having control of the window, the GPU is what's having control of the window. So it'll go to the GPU and give that access to the window. It's technically still under control of the operating system, but we have to tell OpenGL to use the GPU, and the GPU will be able to actually draw in the window because the operating system isn't having its iron-hold grasp over the window. That's what the whole GL context thing we're about to do is all about. Okay, so now that we know what we're supposed to be doing, we can use SDL to do it incredibly easily. So what I'm going to do is in my display.h, I'm going to create a new variable. It's going to be an SDL GL context. That's going to be, guess what? Our OpenGL context that we just talked about. And I'm just going to call it MGL context. So, there. And right after we create the window, we're going to do exactly that, create the context. And SDL makes this really easy. You just have to use the method SDL_GL, create context, and it's for a specific window, so just pass in the window you want to create it for, such as mWindow. And there, we now have an OpenGL context ready, set up, and we can draw in this window, this display rather, using the GPU. I know it might seem a little trivial that we talked all about that for this little piece of code, but believe me, if you're ignorant of what's going on here and you aren't paying attention, you can run into some really nasty and hard to track down bugs. So even if SDL makes it easy, it's important to understand what's going on here. And all we have to do now is delete the SDL stuff, the window in the GL context. So SDL GL delete context, just going to delete the context, and make sure you're doing it in the reverse order you created it. So if I'm creating the window first, then the context, so you want to delete the context first and then the window. Otherwise, you can run into some weird allocation bugs, so yeah. Or maybe they fixed that, but at least that used to be the case. At least I'm pretty sure. But anyways, point is, we want to delete the stuff. So destroy window after that, and, well, we're going to just destroy the window. So there. Now we've cleaned up all the resources. We have a display. We can draw in with OpenGL. Just about everything is done. There's only one more thing I want to do, and that is I want to create a method, void swap buffers. This is where the double buffering thing we've talked about is going to come into play. This is our one method, so I'm going to create it in here. I'm going to implement it, I should say. Void display underscore swap buffers. And this is really easy with SDL. You SDL GL swap window m underscore window. That'll swap the buffers. And I'll show you what that does in just a moment. Like I said earlier, double buffering involves creating two entire blocks of memory, each of which can contain the entire display. And here's what we can do with that. We can have the window display one of those blocks of memory, and we have OpenGL draw to the other one. So for example, the window is just displaying nothing, while OpenGL's down here chugging along, drawing, and eventually coming up with this. So at this point, OpenGL's finished the drawing, and the window still hasn't seen anything. This is where we swap the buffers. So instead of the window being this one, the OpenGL pointing to this one, they swap. So now the window is displaying what we've just drawn, and OpenGL is now drawing to this new upper buffer. And so OpenGL is chugging along, doing whatever, comes up with this, I don't know. And then, at this point, the window is still displaying the old image, so what we can do, we can swap. And now the window is displaying the new image, and OpenGL can now draw to this other one. And the idea here is that the window is never displaying something that's in the process of being drawn. That way we never see like something that's half-finished drawing or drawing in progress, which can cause some really odd visual effects. So yeah, that's the reason we're doing double buffering. That's how it works. That's what it's for. And now, at this point, we've finally done just about everything there is to setting up the window. So now we can actually do some OpenGL stuff. Now, this is where our library gl/glue.h is going to come in handy. So what I'm going to do here is I'm going to create a gl enum, that's one of the glue's constructs, and I'll call it status. And that'll be equal to glue init. So we're going to initialize glue. Glue's going to search through our operating system and find every single OpenGL function that, well, we support. And if the status is not equal to glue underscore OK, then we got a problem. So I'm going to include iostream and just say std_c_error glue failed to initialize. And endo. And there, at this point, we have access to OpenGL code and OpenGL functions. We've initialized glue, it's found everything, and great. So at this point, now all we have to do is really just test out our display. Unfortunately, testing the display isn't completely straightforward. The operating system is still sending our display events, and we're still going to have to handle those events, or the operating system is going to think we're not responding and it's going to crash our application, and things just aren't going to work out very well. So, in our swap buffers method, actually, you know what, I should rename that to be more accurate. I'm going to call it update, because it's more of an update thing. We're going to swap the buffers, and we're going to do something else. We're going to handle events here. So I'm going to say SDL event E. This is an operating system event, that, or at least it's storage for one. And what we're going to do here is we're going to say while SDL poll event. This is going to look for any operating system events that we found. And we're going to pass in the address of the event, and that's where it's going to store it. And there. And what we're going to look for here is if E is equal to SDL quit. Or I should say e.type is equal to SDL quit. If that's the case, then I'm going to have some boolean here called, I don't know, is closed, and when I initialize it, then is closed is going to equal false. We're not closed. But if we've quit, then, well, yeah, we've closed the window. So is closed is equal to true. And I'm going to have a public bool method, which will say, I don't know, is closed, and it's going to do exactly that. It's going to return if we're closed or not. And that's all we're going to do for event handling. We're just going to record if the display is closed or not. And pool, make sure you're saying display : is closed, and just want return, I should probably call it _, is closed. Just, you know, because that's my convention. There. And now with that, we should be in a position to actually do some very basic usage of OpenGL with our display here. So, now that we've finally done all that, I'm going to create a while loop. It's going to be while not display is closed. While we're doing this, what I'm going to do is I'm going to just fill the display with some color using OpenGL. So, to do this, I'm going to want to include gl/glue.h, because that has all the OpenGL functions that we've loaded. I'm going to call the GL clear color function that will set the clear color to some specific color. I'm going to set it to 0.0f, comma, oh, I don't know, 0.15f, 0.3f, and 1.0f. Sure, there you go. There's a clear color for you. And while we haven't closed, I'm going to do that. I'm going to call clear. I'm going to pass in GL_color buffer bit. So it's going to clear the color buffer. In other words, it's going to fill all of our colors with, well, this color. And then I'm going to say display.update. And, well, let's see what happens. So let's build. It shouldn't crash, and we should be able to run. And look at that! We have our display. It's being filled with that color. And there. So I guess the only thing that I still need to do in this video, since we've achieved our goal, is just have one method that does this, because clearing the display is going to be done pretty commonly. So I'll say void clear. I'm going to take in float R, float G, float B, float A for red, green, blue, and alpha. And basically I'm just moving this method or this clearing thing we've done into a display function, which make sure you're saying display : clear. And I'm going to move this over here. And I'm going to set the clear color to R, G, B, and A. There. Now I should be able to say display.clear and get the same result. Oh, and of course pass in 0.0f, 0.15f, 0.3f, 1.0f. And build and run. And you know what, because it's bothering me, where's that warning again? Oh. Because it's bothering me, I'll just set this to void, because if we're not returning anything, we're not earning anything, so there. No more warnings, and we have a display, and we're able to draw in it with OpenGL. Granted, right now we're just filling everything with this bluish color, but still, we're able to draw something in the display with OpenGL. So there you go. Hope you enjoyed, hope you learned, and I'll see you next time, which, now that we have all the ridiculous display nonsense set up, we should be able to actually start drawing more interesting things in our display. Thank you. See you then.